Hello, everybody. Thanks for having me here. I am a cardiac anesthesiologist by day, and by night I started about 3 years ago a team to do clinical data science. So I'm going to talk to you about that, and I'll be the first to say that it's a stretch to go from this to social connectivity and communication, but I think we can get there, so we'll go. So what did we see as the problem? Most of the electronic health records, the platforms are pretty dumb. The algorithms that they run, if they run anything to identify patients who are sick, who have issues, are very simple, rules-based. They don't allow any sort of sophisticated prediction. So we, starting about 3 years ago, got some people together, and their names, I'll just back up a second, are all listed here, and I want to shout out, because they're not here, to Arash and Prem, who are our leads, and to my co-director, Robbie. And we said, let's build a platform that takes all these great technologies that have come up in the last 10, 15 years and lets us generate predictions in real time and send them to clinicians. So it's a little bit touches on what Anthony said of professional performance, but it's also about connecting clinicians to the patients that they should be seeing or talking to. This has been rolled out for 5 use cases across 4 hospitals. For those of you who don't know, Mount Sinai is now a big health system, so there's Mount Sinai Main Hospital, which is here, or I guess this is MSH. Then there's Mount Sinai Queens. Then there's St. Luke's. There's Mount Sinai West, which used to be called Roosevelt. So we're running at all these places, and we're running lots of different algorithms. It's this big platform. Without getting too much into the technical weeds, it runs on Mongo. It uses Spark and Scala. It generates predictions every minute or so. Anytime new data comes in through the interface engine, which our hospital, we're fortunate enough to have an interface engine that aggregates data from all these different health systems, because I think there's something like 130 different technology health platforms running at the hospital at any given, and this is a big hospital, so there's a lot of platforms. But any place you go, there's going to be this huge mix of legacy systems, newer systems. They don't always talk to each other great, so people put in interface engines. We take data from the interface engine, we generate a prediction, and we send something back to the clinician. So the one I want to talk to you about is called Rescue Me, which is the snappy little title that stands for Real-Time Streaming Clinical Use Engine for Medical Escalation. So get me to the patient who's sick and let me help them. So what do? We grab data from their labs, from their vitals, from the nursing flow sheets, which say things like patient resting comfortably, or patient has altered state and was drowsy. Their basics of the EKG, so they're in sinus rhythm or they're in atrial fibrillation. And then we had trained a random forest model on historical data, so 5 years or something, a couple 100,000 patients of historical data, training, validation, cross-validation, all the things that you know and love about training random forest models. And now we actually deployed this. So this runs in the hospital. And because this is touching patients in a way that potentially could trigger an intervention, we decided to do it as a trial. Some of our other models, which simply just are more operational in nature, we didn't feel like it was important to consider the protections of subjects and whether they are going to be potentially harmed. But this one, certainly you could be helped, and our argument is that you can't be hurt, but we still wanted to do it as a randomized trial. So what happens? It runs this model. It says, oh my God, the probability that you're going to deteriorate and go to an ICU 6 hours from now is 0.75. That's really high. Let's notify some people. So it sends, through that interface engine, a message to the nurses. So the nurses in this hospital have these little voice badges. They're voice over IP devices. They actually have Easter eggs in them. So if you say beam me up, Scott, you can like get Star Trek things in them, but that's separate. But it sends, and the nurses can acknowledge. So they're used to, if you press the call button in the patient room, it calls the nurse, and their little vocera says, Mrs. Jones in room 305 wants you to come, and they go. So we send them a message, and simultaneously, for the really sick ones, we send a message through this app called Curator, which is one of these secure texting platforms, to the rapid response team. So there's a team of physicians here who are trained intensive care physicians whose job it is to respond to patients who are getting very sick on the floor. And a sample here of the prediction on the right side. So the probability is 0.74. There's a bunch of components of the probability. Their pulse is a little high. They're really old, right? They're 95. Their blood pressure is kind of high. Their systolic blood pressure, SPP, is 150, which, normal is less than 120. Their creatinine, which is a measure of your kidney function, is really high. So they're a sick old person. But the patient, the SA, who's ever that is, one of the intensivists goes and sees them and says stable, improved. Had bouts of rapid RVR is a high heart rate where your atrium, the top chamber of your heart, is going really, really fast. The bottom is responding to it and also going really, really fast, so you're sort of unstable. But this patient's okay. And so we send these messages 2 or 3 times a day. So what's the challenge or the thoughts for you? So we get these messages back. We don't really do anything with all this information, interesting stuff that people say. Stable, overall improved. We'll suggest medication optimization. So right now, this kind of just goes back into our database and is a black box. But it would be cool if our algorithm actually learned from this. Now it's hard to do, but that's the challenge. And it would be interesting to have a chatbot that could respond to SA and say, thank you. Do you think the patient should get more of this or that? Again, electronic health records are pretty dumb right now. There's a ton of information in them, and it's locked. And big electronic health record companies want to free it, but I don't know if they necessarily have the insight or the innovation to free it because they're stuck in their old models. So I think there's a lot of interesting ideas here about how you can connect caregivers, in this case, intensive caregivers, to patients who need them, but then how you can go beyond that and get some interactivity that may either improve your models or improve the care. So that's where I'll end, and I'll pass it back to you guys.